Okie dokie. This is exercise 8F question 10C. They want to know what is the x to the power of 6 term if you were to do this expansion here. Now, this is different to some of the other questions because we've got our binomial expansion here, but then we have to come along and multiply everything by 2 minus x by another binomial, right? So if I was to expand this, I would use the formula here and come up with this sum, right? This is the part that we would like to consider first. A to the power of n minus k times the b term to the power of k, where I'm thinking of an a plus b all to the power of n, right? That's an n. Okay, so if we did this expansion, I'll get rid of that general sum formula now, and let's just think about doing this expansion. We'd be saying, first of all, we've got n choose 0, which is 1. Then we'd have the 3x to the power of 9. That's the n minus k, n minus 0, 9 minus 0 is 9. Then we'd have our 1 to the power of 0. Then we'd plus 9 choose 1, and so on. 8, then we have 1 to the power of 1. I might skip a few. Let's go down to the to where the power would be 6 and where the power would be 5. So I'm skipping the next term because I can't be bothered writing it out and I might not have enough room. So where when we get to the fourth term, right, where the k or r, whatever letter you like, is 3, you'd end up with this, 3x to the power of 6, 1 to the power of 3. And then the term after that is also of interest. And we'll explain why in a minute. 3x all to the power of 5, 1 to the 4. And then there's, however, 5 more terms until we get to the end. The 9 choose 9 is the last term, all right? I'm just interested in these two terms, all right? Because these are the terms that will give me x to the power of 6. And the reason for that, we just consider multiplying 2 minus x by these two terms here. 9 choose 3. We've got 3 to the 6, x to the 6, times 1. We can drop the 1s at this point, surely. And then we've got 9 choose 4. Coming from here, we've got 3 to the power of 5, x to the power of 5, times by 1. And just be aware, if I've got a, b, all to the power of some power, well, how would we do that? Sorry, b to the power, so this 3x was all to the power of 6. That's why I've written 6 and 6 here. And this 3x is all to the power of 5. So I've broken that down there. Now what's going to happen is that the 2 and the x have to be multiplied by these terms. In fact, multiplied by every term. All 10 terms from the expansion. When the 2 multiplies by this one, I get an x to the 6, because I'm just trying to zero in on x to the power of 6. And when the minus x comes along and multiplies by this, all right, that's where we will get terms that have x to the power of 6 in them. Right? So therefore, terms containing x to the power of 6 are, when the 2 multiplies by this, 2 times whatever number 9 choose 3 is, times 3 to the power of 6, x to the power of 6, and then being careful here, this is a minus x, so we'll have minus 9 choose 4, 3 to the power of 5, x to the 6. Okay, so I've done this thing here, this term here, times by minus x. I'll get my x's will go up to 6. As you can see, I've written a 6 there. And I've just got to be careful to make that, that's no longer a plus. I've got minus. So all right. So what is this number? I mean, obviously it's going to be some x to the power of 6 term, but I'm really going to need the calculator to work out what these, what the coefficient actually is. So we've got 2 times 9 choose 3 times 3 to the power of 6. Not sure if I can remember all this. 2, how about 2, 9 choose 3, 3 to the 6, 9 choose 4, 3 to the 5. All right, let's see if I can remember that. I'll go to my calculator. Right, so we had no cursor to work with. There we go, that's better. 2 times 9 choose 3 was the first one. And then it was a 3 to the power of 6. And then I've got to remember there was a minus. We're up to 9 choose 4 now. 9 choose 4, and we had a 3 to the power of 5 that went with that number, times 3 to the power of 5. These look like fairly large numbers. 91854. Okay, 91854, so I'll just write in that answer. So this is really collecting like terms. 91854, x to the 6. Sorry about the space there. That's all one term. That's the answer. Thank you.